from the picture you can see what business we're in within flying things, at least part of those. So topic will be about and around and within the innovation aspects of product development within this area. And just to let you know a little bit about where we work, we are in the Volvo Group, which is a transport solution manufacturer for commercial things. So the bulk of the Volvo work is in trucks and buses and things. But a small portion is within the aero engine business, and that's where I work full-time more or less. And what we do then is components for aircraft engines. So if you have flown a commercial aircraft, you probably have had parts from Volvo inside. And then we also have the military side, where we do, we're responsible for the RM-12, which is in the Gripen or JAS, that aircraft. And we also do some space applications. So we are actually the Swedish largest part of the space program in Europe. And we also have an aftermarket business which deals with repair and overhaul of entire aircraft engines. So this is really what it's all about for us, that growth. It's a good word. And I choose it because it simulates, it's a symbol for the growth in the world. We are roughly 3 times as many people now than we were 50 years ago. Or to be more correct, the rest of the world outside Europe and US is 3 times as many. We are about the same. So that means that we are about 10% of the population. During the Second World War, we were about half of the population in the world. And that's getting to us to some extent. There's a bigger market. There's also a bit of competition. So being in this growth world, doing business is quite good. That's quite, especially if you have look into traffic growth. It's been growing about 4% annually, with a few dips when these recessions or incidents has happened. But it also has some more subtle consequences or important consequences. Just one thing on the safety side which is important is that the number of aircraft incidents or failures, the total number, may increase, although we actually have more safe systems. And that's a pedagogic thing to explain, because aircraft accidents are always reported. Although we do things more efficient, the better engines, we still have a problem with increased emission of CO2, for instance, because the growth is bigger than the reduction of or efficiency gain. And obviously the competition thing is also there. So you can ask yourself if this is sustainable. Is this the way that we can continue to work? That's definitely something that we as individuals consider daily nowadays. But companies have a bit of a problem to relate to that, actually. Anyway, there is a need for innovation, how to deal with these kind of situations. And obviously, organizations, people, and companies act on this. And within our business, we follow some international agendas that we work with. In Europe, we have Acare, which has stated that we promise of 20 or it should even be 50% reduction of CO2 emissions until 2020. And IATA, who is the aircraft or the airliners organization, they have the vision to build zero-emission commercial aircrafts by 2050, and also have a carbon dioxide neutral growth from 2020. And you break it down, it means that an efficiency in terms of fuel efficiency that has to be on the level of 1% or 1.5% per year, every year. They have to become 1.5% more efficient. They have stated this in these kind of statements in agendas, and that's actually the policy that we follow when we do research and we do investments and development. Acare, the other one, the European one, illustrates it like this. They did it a few years ago. You can see the current the CO2 emission, or actually the fuel consumption, which is quite close to that, listed from the 1970s, the aircrafts that were launched around 1970s, the Boeing 737 and Airbus 300, etc. They are still in operation, but they are being phased out. You can see how each generation of aircraft is getting more and more efficient per passenger. The target, as you can see in the red area, is quite close and it's quite challenging. If you extrapolate a little bit, you can see that there is a bit of, it's not an easy target to get. And 2020 is actually the engines and the aircrafts that we are developing now. IATA has a similar view. They've broken down how to meet these emissions. If you look in the large curve here, you can see how things would be if we don't do anything. If we just continue to let aircraft traffic grow without any action, then the large, deep down to the green line, is actually flight renewal, which means that buying new equipment. And that's very good for us on the manufacturing side. There is a big incentive to buy new things and get out the old ones. So it's in that way it's a healthy thing. It's quite ambitious. These 200 airlines estimates that they will spend $1.2 trillion to meet these objectives. So again, to achieve this kind of growth in some kind of sustainable way, or at least without violating too much, we really need to think a bit different. So what are we doing? I'll choose to say some words about what we do in Europe on the European level. And then we actually have a large program, a very large program in the framework, which is called Clean Sky. How many of you have heard about Clean Sky? A few? Yeah. That's they've organized a massive amount of resources in research to validate and develop new technologies that meets these or addresses these targets. So they focused especially on the carbon dioxide and the NOx, and also the noise emission. Noise is considered to be an emission as well. So we are actually developing together with our European partners that kind of technology. It's divided into 6 areas. It's on several of those are on aircrafts, they are on helicopters and equipment, and they're also in down there you have the sustainable and green engines, which is a portion of this initiative, where we then develop several demonstrators really. And demonstrators in this case is building new aircraft engines that will be able to meet these kind of objectives. You can see some of them. There are four they are called Sage or Sage, and we are actually involved in doing components for these kind of engines. And as you might see, they look a bit different. The first one is counter rotating structure. You're actually designing a new architecture for the entire engine. So it's a quite massive shift for us. It's like putting the wheels on the roof for a car or something. And they are tailored to meet aircrafts, obviously. So in parallel in the other programs, you develop aircrafts that matches these kind of things. And there are lots of technologies that is validating in these programs. If you then look into our perspective as a company, we follow a development thinking where we start off strategically in the bottom here, doing a lot of research on identifying and developing technologies. We then validate them on the second level, the international program level. And then finally we do the development, the actual product development for the intended aircraft. So here it's one thing that is important to note when we talk about innovation, especially creativity. The further up you go in this, the more sensitive to risk you are. So when you're actually doing your development program in the top there, you don't really want to have any risk at all. So product development from this perspective starts where you don't have any risk or very low risk. So then the more creative side, where you find radically new solutions, that's done actually on the lower level, so to speak, where we can do more explorative studies. And just to conclude with our pitch on this is that since we are not doing the combustors and those things in the engine, we are doing the skeleton parts in the engines, the structures. Our main contribution, initially at least, is to provide low weight. So we try to do the components as lightweight as possible, and that actually has a quite significant impact on the carbon dioxide, because it's very expensive to lift and transport weight through air. So if you can do things lighter, then it's a lot of gain. Then, so far it has been quite, I would say, traditional if you are a technologist. You see the targets, you can derive the targets for that one, you can actually formulate requirements, what would be required for a new product. But is there another way of thinking? Perhaps. So this is the first question to you. And is there another way which we can reduce fuel consumption or CO2 rather than developing a lot of technologies? Open question. Good. That's definitely an option. But then we must put another boundary then. If you want to fly, or if you want to go from A to B, let's say across the ocean, in some limited time, if you accept that, then is there another alternative to reduce that fuel consumption again? Yes, perhaps not fuel consumption, but then for you can reorganize, and that's actually happening. It's actually being certified now, and they are building up not only research facilities, but also, I think from next year they will certify fuel. So I think there are at least 5 companies who have flown commercial routes with alternative fuels. So we are getting there, but it's still an energy problem in total to do it. I think it's much simpler. You can actually land halfway. Then you don't need to fuel the aircraft very much. So you don't have to spend fuel to carry fuel. Obviously it takes a bit of time, an extra hour or two. But just to see that you can do other things than simply just to improve efficiency of each component. So what I'm driving is that there is a system here. And often the solution may be that a combination of technology and something else. And we can see this happening, and you've probably seen it happening as well. This is an example from Volvo car. I don't know if you've seen it. It's been on TV this fall, I think. That they provide a service where you can, they call it Service 2.0. For a small fee, you can actually get an upgrade of your software every time you visit the workshop. You've seen that? I think it's quite brilliant, because what they actually do is they don't have to bring back the cars. They can actually upgrade them and actually charge us for that and provide it as a service. Because the alternative would be then actually to call back the cars, at least in some cases. It's just one example where you link in a service with the product provision. In our business, on the commercial side, Rolls-Royce, which we one of the OEMs or aircraft engine manufacturers, they provide something called total care, which means basically that they take a lot of responsibility for how to operate the engine, and they also have an economic model to charge. They pay per use, basically. So depending on how much you use it, you also pay for maintenance and things following that. So they actually have another accounting or billing model. And that's quite simple, because the reason is that the so-called aftermarket, or the after sales market is quite significant from a revenue perspective. So the Rolls-Royce is actually, they earn some money from selling the engines, but the main part is from the after sales business. It's actually led to some of that we have redefined the definition, or we that traditional areas such as manufacturing has another definition nowadays, at least again to the European policy documents. If you read this one, manufacturing is a means to creating value from things that are made and recovering maximum value from the product or product ID, including delivering service through life. So this is the European way of defining manufacturing. I don't really remember, but I don't think it was the same way 10, 15 years ago. So actually, this is a way to see that what we are doing in manufacturing is a little bit more than simply cutting and assembling pieces of equipment. Okay. By now, I hope you get the idea about there is something going on out there that may impact how we do innovation, how we bring things to the market. Okay? So how do we do then? That should really be an open question as well. But the Volvo Group has an ambition, a clearly stated ambition. The CEO of Volvo, Leif Johansson, stated a couple of years ago that by 2015 we should double the amount of revenue coming from what is called soft products or soft sales, which is essentially the add-on services for our products, the physical products. And with the definition of that is that soft products are all the products and services sold to a customer that enhance the customer experience and satisfaction of other than the sale of new vehicles, equipment, or engines. So it's compare that to the Rolls-Royce picture I said before, that you actually want to have revenue, or you want to have the business, a significant part of the business from the add-on value to the actual component, which means that, okay, you can sell a truck or you can sell an engine, but really the business case is to keep order of that one or maintain it or provide services around it. So you can do that in many ways, and many companies have done it. IBM is well known for done this a few years ago. IBM, as you probably know, became famous for manufacturing PCs, and they tried to do it even when they were not successful. So they nearly got bankrupt in the 90s. So until in the late 90s, a new CEO said that, well, we're actually not going to do PCs. We're going to sell services or provide services. And now they are big again. So they're a well-known example for a company in the manufacturing area who has actually transformed into a service provider. This is happening in some sense in many places. And for the Volvo case, it's still important to have the basis on and in the products, the physical products. Quite a few companies, a number of companies have tried to go into only providing services, just get rid of the development and production, it has not been successful, so to speak, because the basis has to be in the know-how of the products, at least for manufacturers. So sometimes we refer to it as product service systems or functional products, where you combine products and services. So what's then different from traditional product development? This is a very, very high-level, simplistic picture of product development. There is some kind of market analysis or request or agreement with a customer or a user, and then you have some kind of requirement specification based upon that. And then there is often a product development process that you run through to develop these kind of products. In our case, we do it by actually verify each requirement, find solutions and verify those. Then we are safe and deliver a product. If we then talk about solutions or product service system, we loosen up that it actually only is a product that will be the end result. Then we should actually start off looking into the needs or what's actually the need and understand the need and then deliver some kind of fulfillment to that need. In our case at Volvo Aero, it's quite tricky because we do something called contract-based development, which means that we negotiate everything. You remember this flow with where you develop things from technology to validation and products. We do a lot of negotiations just before we start, so then we tie up the requirements in contracts, and then when we have defined the contracts, then we can go on doing development, and then we don't want to divert from that one because that's quite risky. So how can we actually define precisely the needs? That's probably not possible. And how do we verify that needs? Can we really use the traditional product development process? That is actually defined in quite a few of the development companies around. Hang on that for a second. Then we go back and let's start with the basic things in service, where you actually have a service provider, which could be a manufacturer that we've seen, and we have a user. Those two roles, a green guy and a black guy. And then look back to what happened roughly 100 years ago or more, where we had the pre-industrial area. How did you do when you wanted a product? Well, you found some handcraft guy who could explain what you needed, and he could actually query back and ask back, well, what do you really need? Well, would this do? And it's what is a negotiation. And then you started to develop things, and he probably interacted with you quite a lot. The same way as we actually do today with carpenters back home. We think that we buy a new kitchen, but then when they come, they have ideas and negotiate, and hopefully in the end you have some kind of satisfactory solution. Then someone said that this is not very rational because it's too expensive, and you start to do industrialization and do economy of scale kind of things for 100 years or so. And what actually happened is that the ones who did the things they lost contact with the customers. But they were very skilled in doing the artifacts and the physical things. And this you can actually see, and now we've been talking about supply chain integration and everything for some time. You want to facilitate the dialogue within the enterprise, and you have a number of companies that has to be organized together. And for us, we are actually on the third tier here. We have the customer, which may be a passenger, and then you have the airline providing the service to the customer, and then obviously you have the manufacturing chain with the OEMs and the aircraft manufacturers who provides the equipment for the service provider, and then obviously we have on lower tier levels we are providing components for those engines, etc. So it's not very easy for us. Who is the customer and who is the user? It's not easy for my colleagues to relate what we do with some kind of user service feature. There are links, but they are not always that easy to trace. So you have a business-to-consumer relation in the end step, but then the rest is actually business-to-business relations, which means that there are professional companies and contracts being signed. What we do is we develop these things together with the OEMs, and we do business contracts. We are actually a part of Rolls-Royce when they provide the total care, business-wise. So looking a little bit future-wise, the ideal picture would be then that we have the user situation near at hand, or we understand it perfectly well, so we know the needs of the end product. So we can do trade-offs on any level, and we understand that relation. That would be theoretically at least an interesting idea. And then actually everybody in the chain would know what they are doing and what kind of value they provide, etc. Now, the truth may be probably somewhere in between, but there is at least a good trend towards recognizing the understanding of the user value in the end. So I'll make a short pause here on summarizing some of the challenges. There are probably more, but one of them is that the value versus cost. If you look into manufacturing industries such as Volvo Aero, there's quite a lot of focus on cost because that's a competitive means. Naturally, so it's easier to reduce cost with 1 krona than actually gain a krona, because you have control over the cost yourself most often. But if you then want to provide things as service and add value, that should also be a driver for development. This is something that we look into in research together with LTU. It's also a bit of a cultural and organizational challenge, because all these large manufacturers such as us, we have developed organizations and cultures and decision principles and tools and whatever to deal with this thing that we actually develop an artifact only, and then someone else does the business. Hopefully the marketing or business guys do it, but it's not very tightly coupled, to be honest. We have processes for developing products. Services have been more like establishing the business offer, and it's not been developed, not at least in our case, with any kind of process. It may be that it's not possible to do it. You remember the question then I had with if we can develop solutions through a development process? If so, how would then a process look like, where you develop these kind of products and service together? Another very practical thing is that a service, definition of a service, that it is being consumed as it's being produced. I mean, you consume you're watching this kind of events and you consume it the same time as I produce it. Whereas a product is produced first and then you can verify it, and then afterwards it's... So there are some kind of fundamentally different things we talk about, but still they are a part of the total solution. And then there is a lot of things, if you come from the hardware side, things like quality. What is the quality of a service or a function or a success? How can you measure that? If you want to do something up front, if you want to design a service, how do you really know it works? It's, as an engineer, it's a little bit difficult to run finite element analysis on a service. We can try, we have. These kind of questions are the kinds of questions that we have to answer on. And it's probably true that the ones who can answer and understand these questions well, they probably have a good chance of being successful, because they can do something good out of it. So we have some examples. We have actually started a little bit. So we actually have developed a process recently within the Volvo Group. We have already processes for product development, the physical thing, but we have now actually released a process for service development that is intended to be used in parallel or together with the hardware process. It doesn't look like a process, really like a block chart with things. It looks like a series of iterations, and it's done deliberately so visually, because there is first an exploration phase, and then there's a conceptualization phase, and a building phase, and a test phase, and a launch phase, all within which you actually interact with the user and customer. So you have that kind of loop. Of course, you need that to be able to at least get some kind of validation or verification of if the service is good or not. So it's a bit of a more co-creative process. Funnily enough, that has been considered to be a criteria for good product development as well. If you go down to the engineering level, does it have any implication there? This is a result from one of the development research project we did here a few years ago. We asked ourselves, is it possible to actually at the same time define a service and a product? And we call it a functional product, and then we did a functional product development tool or implementation. So the functional product is seen as a product. We took a product perspective and said that the features of the product are actually labeled, so you can see them. Perhaps you cannot, but it says training and information, knowledge and culture things. It would be properties of that product. So if you have that definition and include that, then you should actually be possible to model it and understand it and define it, we thought, perhaps. So we did an example of a classical thing. It's very hard. It's titanium. It's a structural component within the engine. It's a very classical thing that we do at the develop and manufacture at Volvo. So, and it's done with hardware-focused engineers. There's a lot of challenges within that as well. A simple flange. We took that as the example and incorporated some of the life cycle effects and manufacturing and maintenance effects as properties. So we added those onto the product and actually try to link those. So in this one you can see a classical CAD interface where we actually put properties on each surface, and the properties were the link to the behavior of the product. So for instance, the tolerance, how fine or refined the surface is, or the tolerance within the holes or the flange, could actually be tied to how it's manufactured and how it's being maintained. And then you can actually, in this case, the table to the right is the operations list for manufacturing, which normally is based on a drawing setup, a set of drawings that the designer goes to the production guy with, and the production guy, he looks at the drawing, or for all that matter a CAD model, and then he generates this list of activities to be able to assess the manufacturability of that. Now it's actually being designed at the same time. So then the question arises, who's really so we generated this list automatically at the same time as we did changes on the product model. So then it comes to the question, who is really the designer? It may be the production guy who is sitting behind the table. So you can see it's quite a simple example, but it actually challenges a bit how we work. And that's the second, or close to this last one. It's really the way we work is not the same. We use different means, and it changes over time. And very few, when I started working, we had actually a few guys working with a drawing board, but now we have to dig quite deep to find a drawing board. Whereas the new generation, your generation, and even younger generations, they have a totally different means of designing or interacting with environments or computers or whatever. And we would like to use these means. So it basically says that things are changing. And this is just one example that we did whole engine simulations, Marcus, before as well. But we did it by building wood mock-ups. So we actually spent a lot of effort in building prototypes out of wood to understand the mechanical behavior of the engines. Nowadays it's more or less virtual, at least in the development phase, where you can actually interact with a virtual model to a lot easier than we did before. And you can definitely create these kind of models more rapidly than we did before. So I will actually try summarize this session with raising a question. That will be, what kind of means and competences do you bring to us? And keeping in mind that most employees at companies where you will start work actually have an education who is at least 5 years, probably more old. The ones who take decisions actually went to school, hopefully university, perhaps during the 80s or 70s. So how can you actually, what's your contribution in this respect? And how can you, with your means and your insights and what you learn, how can you bring that into improvements in how we work and understand the situation? I leave that question open, just as a consideration. Okay. Thank you.
Thank you, Ola. Very nice presentation, very interesting, raising some very interesting thoughts about product development in the new sort of millennium. Do we have any